class, this is lesson 7.2. Use the converse of the Pythagorean theorem. So the converse of the Pythagorean theorem says this. If a squared plus b squared equals c squared, then it is a right triangle. So before we said if it's a right triangle, then we know a squared plus b squared equals c squared. Now we're just doing the converse. So if you can say a squared plus b squared equals c squared, then you know it's a right triangle. So for our first example, tell whether the given triangle is a right triangle. So, is it a right triangle? What we need to know is, does my leg squared, which one of them looks like this would be a leg and this would be a leg, so does 6 squared plus 9 squared equal 3 times the square root of 13, that whole thing squared? That's what we're asking ourselves right there. So let's simplify both sides. 6 squared is 36, 9 squared is 81. If I give this squared to both of these, well, 3 squared is 9 times the square root of 13, and then I square that, it's just 13. 36 plus 81 is 117. 9 times 13, yep, that's 117 as well. So those are indeed equal, so yes, it is a right triangle. Our next example here, tell whether the given triangle is a right triangle. It looks like this is a leg and this is a leg. So we're asking ourselves, does 24 squared plus 16 squared equal 29 squared? That's really what we're asking ourselves. So 24 squared is 576. 16 squared is 256. And then 29 squared, well, that's 841. So 576 plus 256 is 832. When we said 29 squared is 841, those are not equal to each other, so no, this is not a right triangle. So here's a couple that I highly suggest you pause this and try these ones on your own and make sure you get them right. So this first one, it looks like 4 and 5 are our legs, so we're going to ask ourselves, does 5 squared plus 4 squared equal 2 times the square root of 10, that whole quantity squared? Well, 5 squared, that's 25. 14 squared is 16. If I give my squared to both of these, 2 squared is 4. The square root of 10 squared, well, that's 10, so it's really 4 times 10. 4 times 10 is 40. 25 plus 16 is 41. So those two are not equal. So no, this is not a right triangle. Looking at this next one, it looks like 18 and 15 are our legs. So we're asking ourselves, does 18 squared plus 15 squared equal 3 times the square root of 61, that whole quantity squared? That's what we're asking ourselves. 18 squared is 324. 15 squared is 225. And then give your squared to both of these things here. So 3 squared is 9. The square root of 61 squared is 61. Let's simplify both sides. 324 plus 225, that's 549. And then 9 times 61, well, that's also 549. So, is this a right triangle? Yes, because my two sides are equal to each other. Let's look at the other side of the page. All right, here, so we're classifying triangles now. It says the converse of the Pythagorean theorem can not only be used to determine if a triangle is a right triangle, but also if the triangle is acute or obtuse. So, looking at our box here, methods for classifying a triangle by angles using its side lengths. First one is theorem 7.2. So it says if c squared equals a squared plus b squared, then the measure of angle c is equal to 90 degrees. Okay, so if this equals the two legs squared, our hypotenuse equals the legs squared, then we know that this is a right triangle. The next one, if c squared, our hypotenuse squared, is less than our two legs squared and added together, then the measure of angle C has to be less than 90. So that makes triangle ABC an acute triangle. And then the last one here, if c squared is bigger, so our hypotenuse squared is bigger than the sum of our legs squared, then the measure of angle C must be greater than 90. So triangle ABC is an obtuse triangle. And I think this is really pretty easy to remember. If your hypotenuse squared is equal to the sum, it's right. If your hypotenuse squared is less than the sum, it's acute, which less than 90 is usually we think of as acute. Greater than 90 we usually think of as obtuse. The key thing you got to make sure is when you're doing these, put your hypotenuse squared first. All right, so let's actually use this. So here's our first example. It says, can segments with lengths of 2.8 feet, 3.2 feet, and 4.2 feet form a triangle, first of all? And if so, would the triangle be right, or acute, right, or obtuse? Okay, so we're going to use the triangle inequality theorem, and this tells us the sum of any two sides of a triangle is greater than the third side. So if you add any two sides, it must always be bigger than the third side. So let's test this first. So if I do two of the sides, 2.8 plus 3.2, that equals 6, and 6 is greater than 4.2. So those two legs work. The other two, if I do 2.8 plus my other side is 4.2, well, that equals 7, and 7 is definitely greater than 3.2. Let's find our last three sides. If I do 3.2 plus 4.2, well, that equals 7.4, and that is definitely bigger than 2.8. So can this be a triangle? Yes. So now let's use the converse of the Pythagorean theorem. If this was a right triangle, our hypotenuse would be the longest side, so we have to put our 4.2 first. So 4.2 squared, we're always going to put our longest side first here. And to figure out what kind of a triangle it is, we're really looking for what's this sign in here. So 4.2 squared is what, then, our two smaller sides, the sum of them squared. So if I do 2.8 squared plus 3.2 squared, if you put that in your calculator, you'll get 18.08. Again, we're looking for this sign right here. If you put 4.2 squared in your calculator, you'll get 17.64. Well, 17.64, that is less than 18.08. And since we set it up right, we put our longest side, what would be our hypotenuse, first, we know that we have an acute triangle. It's not our hypotenuse because it's not a right triangle, but our longest side must go first when we're doing this. Okay, I'm going to pull my screen up a little bit here so we can see it. These are the last two. So can segments with length 6.1 inches, 9.4 inches, and 11.3 inches form a triangle? And if so, would it be acute, right, or obtuse? So we need to first test it to see if it can be by adding our sides. So 6.1 plus 9.4, you add them, you get 15.5. And that is definitely bigger than 11.3. So that works. Our next two sides that we'll add are 6.1 plus 11.3, and that equals 17.4, and that is definitely greater than 9.4, our third side. And our last thing that we must test is 9.4 plus 11.3, and if you add that together, you get 20.7, which is definitely, again, greater than our third side, which is 6.1. So these can form a triangle. So now let's do our second step. Let's set this up right. We're going to put our longest side first. Our longest side is 11.3, and we're going to square that. And 11.3 squared is what? We're looking for what's our sign here. Then the sum of our two other sides squared. So we have 6.1 squared plus 9.4 squared. So 11.3 squared, if you put it in your calculator, you'll get 127.69. Is what then? We're looking for our sign there. 6.1 squared plus 9.4 squared, if you put that in your calculator, you get 125.57. So the sign that would go in there, 127.69, is definitely greater than 125.57. Since it's a greater than sign, we know we have an obtuse triangle. Let's do this last problem here. Can these three segments, 4.3, 5.2, and 6.1 feet, form a triangle? And if so, would it be acute, right, or obtuse? So first, again, let's test our sides. So 4.3 plus 5.2, that's going to equal 7.5, which is greater than 6.1, so those two sides work. The next side's 4.3 plus 6.1. If you add them, you get 10.4, which is greater than 5.2. Our third pair would be 5.2 plus 6.1, and if you add those together, you get 11.3, and that is definitely greater than 4.3. So yes, this can form a triangle. Our second step is to set it up with our longest side first. So we're going to do 6.1 squared, and we're looking for what's the sign is what then? 4.3 squared plus 5.2 squared. So if you do 6.1 squared, you'll get 37.21. Again, we're looking for what's the sign here. If you do 4.3 squared plus 5.2 squared, you'll get 45 and 53 hundredths. So now we're asking, what's our sign here? Well, 37 and 21 hundredths is going to be less than 45 and 53 hundredths. Since that's a less than sign, we know we have an acute triangle. All right, this is the end of lesson 7.2. Make sure if you have any questions, you ask me about it, and have a fabulous night.